Afternoon to one and all. I'm Dr. Suchita Rawat. I've done my MPhil and PhD from University of Delhi. I have an experience of 5 years in teaching and 6 years in research for my MPhil and PhD. So in today's session, I first of all thank the organizer for giving me a keynote session at this moment. So I will be presenting a bibliometric review of machine learning application in food adulteration detection, trends and insights from 2020 to 2024. So we've taken 5-year data set for it. Briefly about the introduction of food adulteration and how food adulteration and food adulteration detection with the usage of artificial intelligence is important. Food adulteration is a widespread issue affecting both developed and developing countries, with India facing significant challenges in this area. The prevalence of food adulteration is driven by various factors, including economic motivation, lack of consumer awareness, and insufficient regulatory enforcement. Food adulteration poses a very significant risk to consumer health and food safety. In purview to this, advanced technologies such as spectroscopy, be it vibrational spectroscopy such as IR or FTIR or Raman, is utilized. And hyperspectral imaging is also used, followed by chromatography and electronic noise or e-noise. Along with that, these techniques are actually played in tandem with artificial intelligence, and they are increasingly being employed to detect the quantity of adulterants in the food products. Artificial intelligence offers rapid, non-destructive, and highly accurate method for ensuring food authenticity and safety. Therefore, there is a continued advancement in machine learning data analysis technique that are expected to further enhance the effectiveness of these detection methods. So, in light to this, the present bibliometric review aims to map the trajectory of machine learning research within food adulteration, identifying emerging subfields and suggest direction for future studies. So now for this bibliometric review, we had used the Dimension AI. It's a database which is free of cost, and it is very useful and resourceful. So the website link is here. A data set of publication of around 4,867 were retrieved using the Boolean search keywords, which were food adulteration and machine learning or unsupervised learning or supervised learning. And this was done in Dimension AI on October 1st. Once we had downloaded this data set in CSV file, we had cleaned the data and excluded review articles, non-research publications, and non-English entries. And once we had carefully reviewed those 4,000, we came up with 187 articles that were analyzed for the bibliometric analysis for WOSVIO version 1.6.20. The time frame that we had considered was 2020, which means that we are covering only half a decade from 2020 to 2024. So 5 years is a good analysis and interpretation to do, considering that this topic is very advancing and nuanced. We cannot go to 10 years bracket. Now moving on to our results and discussion. First, I will be talking about the descriptive analysis. So descriptive analysis with respect to the publication trends, if you can see the line graph here, shows how number of publication in a specific area of journal has evolved over the period of time. So in 2020, when the articles were less, extendedly they increased up till 2023. The decline here is eminent because I did my search in October 1st, so I didn't cover the remaining months, which is October month itself, November and December, so 3 months lag. So therefore, probably a dip here is seen. Otherwise, the trend is going upward only. So moving on to the authorship distribution, the most prolific author in the field, after doing the analysis of 187 paper in WOSViewer, we realized that the authors which are the most contributed to this field were Pastor Hadi with 8 documents, and their citation was 174, which is very remarkable. Then comes Windersheen Anjar with document 5 and citation 72, Kovis Dalton, Menusloglu Ahmad, Roman Abdul, Suranto, Zokyu, John Lewis Zinnia. And here is the density map. So this is a net density map. If you can see, the author that has contributed the most document will have a bigger sphere compared to other authors. So this is how the weight analysis is done. So, okay. So, uh, Pastor Hadi was the author with 8 articles. So the sphere depicting him is going to be much more bigger than the rest of the authors. Then moving on to the institutional analysis that we did in WASPHERE, we found that there are certain institutes and universities that have contributed the most to the literature in the field. And these are Sharif University of Technology with 8 documents, Gadaj Mada University with 7 documents, National Research and Innovation Agency with 6 research articles, State University of Campinas and with 5 articles, Mayer Agar L. Atioma Ni Egetem with 5, China Agricultural University with 5. So now, if you see here again, the Sharif University is going to be having a more dense color. So now this is an overlay map. So bigger the sphere, the more is a contribution that you would feel. 8 and 7 are very close, so these two will have same. However, if merging of the documents is seen, if there is merging of the two color, it means that co-collaboration has taken place. But we didn't observe this in our analysis. When we had viewed this document, they appeared to be very unique spheres without any attachment at the circumference. So this shows that these people are not really collaborating much with each other. However, they have good documents in their research. Now, moving on to the geographical distribution, countries and institutions which contributed the most to the field. It was China with 50 documents. When we say documents, it is research article published from the time frame of 2020 to 2024. And the citation is also really high, which is 427. Followed by Iran with 22 documents, and proudly we can say that India also contributed to 19 research articles which have got really great citation, followed by Brazil, Turkey, Indonesia, Malaysia, Spain, United States, Italy, Ghana, Pakistan, Canada, Hungary, United Kingdom, etc. So again, if you see, this is a density map. The bigger the circle and the more darker the circle, that will depict the more contribution. So if you see here, China, which is number 1 when it comes to research in using artificial intelligence for food adulteration, it was China who came on top with 50 documents. So the sphere here is much more darker, it's bigger, the color is dense, followed by then Iran, and then India. So this is how we interpret our graphs with respect to visualization. So the darker and the denser the color is, the more is the contribution per document for that particular country. Now, if you see here, there is no merging of the spheres, which means that these in the institute are not really collaborating also with each other. However, they are independently working. Then moving on to the citation analysis. For any research, citation plays a very important role because it is citation which acts as a benchmark for us whether to read that research article or not. So whenever we are also reviewing an article, the first thing that we were taught when we were a research scholar was to find the impact factor of the journal. So and our supervisor will make an emphasis that you'll have to read papers initially, systematic reviews, meta-analysis and review, and also mark the impact factor right on top of the paper. So citation plays a very important role. Why it is important? Because a paper which has a good impact factor and a good citation score means that it's a more relevant, qualitative, quality research article which could be actually looked up and worked upon. So citation actually plays a very vital role. So another analysis that we did apart from the descriptive analysis in WASPHERE was a citation analysis where we try to understand which document out of that 187 document was cited the most and who was the author for it. So total citation, if you can see here, the number of citation of a particular paper that has received. So the paper by Amir Wasni in 2021 was the most cited, which is comparison of near infrared and mid infrared spectroscopy based on chemometrics for saffron authentication and adulteration detection. Here also, if you view the spheres, so this again is the density map that we see. So in the density map also, the bigger and the more darker the color of the sphere is, the more is the contribution, which is very evident. So Amir Varsini 2020 cited the number of the number of citation that was given to this article is 92, followed by Chakravartula 2022 with 71 citation. Then comes Borky with 2020 with a citation of 59. So when we look at these map itself, we can actually see okay, so we can actually see a lot of the interpretation. So one is visualization. When I visually see, I can clearly find out the first top 3 individuals. Now moving on to the highly cited authors. For the highly cited authors, there is an author analysis that was done by the software. Now everything that we're doing is based on CSV file that we take. The CSV file that we had cleaned, we have to take it in the same way as Dimension AI has given, without any addition of extra column or extra rows. And from that itself, the VOS viewer software will be used for analysis, and it will take various columns that is required for the analysis. So the highly cited authors that we found out when we did our analysis, it came out to be Pratasar Hadi with 8 documents, 8 research articles. I apologize for this. 8 documents, and the citation was 174. So mind you, this is author specific citation. It has nothing to do with the document specific citation. So document specific citation means a document or research article which has received maximum citation, and author specific is individual, which author is among the top 10 authors. Overview from the analysis that we did. So it was Pestiridine. Again, the bigger the sphere, the more is going to be the contribution. So this is very evident here. Then there were 5 and 4 documents that were contributed. So that means that from the year 2020 to 2024, Pratasar Hedi was the one who actually done 8 articles, which is a good for any research, considering that 2 per average, and those are quality paper, which we'll realize once we go ahead with the journal analysis. So journal analysis is another analysis which plays a very vital role. Once you have understood the descriptive analysis of which country is offering the most work. Second, journal analysis is also important because you'll get to know how these articles have got publication. So this motivates a lot of researcher to publish in the same set of same set of journals, and also for new researchers to begin their research in this domain of AI and food adulteration. So journal analysis, when we did our analysis with respect to curating the journal which published the most relevant research article in field of food adulteration and artificial intelligence or machine learning, not artificial intelligence per se, in that the subfield that we had chosen is machine learning. So machine learning and food adulteration, we found that there are very good documents which have been presented and published by the journals which have great impact factors. So Journal of Food Composition Analysis had published 18 articles from the time frame of 2020 to 2024 with a citation of 137, and its impact factor is 2. Food Control, 17 documents, and it has a really great impact factor of 4.68. Food Chemistry has an impact factor for 8.5, and then the other journals. So these documents are the one which have been published. So again, if you see here, this is the density graph that we call, and here the greater and the bigger the circle is. Now the biggerness of the circle will not be very relevant here, considering that all these numbers are pretty much same, 18, 17, very close to each other. So Journal of Food Composition and Analysis and Food Control size wise will not show any difference because they are on the same document level, which is 18 and 17. Intensity wise, if you see, there also it could be pretty same. So in VOS Viewer, there is an option of selecting it based on the citation or selecting it based on the document. For all the analysis, we had weighed the spheres for the documents, because we wanted to create the graphs based on the document strength and not the citation strength. Then moving on to another set of analysis. So there are two set of analysis that we have discussed. One is descriptive analysis. Second one that we had discussed was with respect to citation analysis, which is an important part. The fourth set of analysis that we had performed on this data set was co-authorship analysis. Now, co-authorship analysis plays a very vital role. It helps us to understand the authors and their work, how frequently they are cited together, showing intellectual influence and collaboration amongst each other. So if you see Paratsar Hadi was the one who was the top author. However, this author is not forming any network with any other authors in the field or in the domain. So now this analysis is done using our total link strength. So your co-authorship analysis, unlike the descriptive analysis or unlike the citation analysis, which is done on either documents or citations, this is done based on the link strength. So when I say link strength, it means that these set of authors are actually collaborating with people in and around their vicinity. So a score of 8 means they're actually collaborating one, which is very evident from this network that is formed. So when we generated this graph, we saw network or linked authors and unlinked authors. Okay, so linked authors are the one which are working together and collaborating, decimating intellectual collaboration or decimating the intellectual knowledge. So here, if you see first, so 3 authors collaborating together and 2 authors collaborating together. However, the most prominent document that has been done, that person is not actually collaborating with the rest of the individuals. So if you see here, his documents, in spite of being number 8, Paratsar Hadi, number 8 documents is actually greatest among all here, but link-wise it is 0. So when we say 0 link, it means that they're not co-collaborating with others for their research. So this also is very interesting, because in future, if you want to work with somebody, you would want to know who is more open, and evidently here we can see that. Okay. Then coming on to evaluating the country's collaboration on research projects in domain of machine learning and food adulteration. So it is noted that, so again, our analysis will be based on the total ring strength and not on documents or citation. So whenever we're trying to go ahead with co-analysis, we always play emphasis to the link strength instead of the documents and citation. Okay, so if you see here, the link strength is 5 for Iran, which means that Iran is a country which is collaborating and has 5 nodes. So this here is a node. So in network, there are 2 terms that we talk. One is node and the other one is edge. So any individual entity, so country here, for example, is going to be referred as node when we do social network analysis. And these curved lines that are going to another country is known as edge. So total link strength is nothing but it will help you us to understand how many linkages they have. Now this is not a live map. So Iran is reflecting 5, one with Canada, one with India. India is placed here, not so 1 here, 2, United Kingdom and United States. So that way it creates around, and there is one more country here. Okay, so 5 links, which means that it is collaborating with 5 links. Now coming to Hungary. So Hungary is nowhere to be seen with 4 strength here, because it has contributed the least amount of articles. So if you see here, strength wise, remember I told you that we are doing our analysis based on the total link strength. However, this link strength is also going to be governed by the documents that they are contributing. So compared to Iran, which is contributing 22, here only 5, which is the Hungary. So in our live network, that was not seen. It was Iran which came up top 1 when it comes to total link strength. Again, I repeat, total link strength is the number of co-collaborating institute that it is working with. So 1 knot, 2 knot, 3 knot, 4 and 5. So if we zoom here, we'll be able to appreciate that there are one sphere here, one sphere here, one for Iran, United Kingdom, and one more country here. Okay, so Hungary, I suppose. This is India. So that way, 5 linkages Iran is making. United States is making 2 linkages, one with China and the other one is with Iran. So when we go to United States, it's going to be evidently seen that way. Okay. So now moving on to the next set of analysis. So far we covered with descriptive analysis, citation analysis, collaborative work, which is with respect to either countries collaborating or authors collaborating. Institute collaborating wise, I didn't represent everything here. So what we are representing is only the analysis in which some link is seen. In few analysis with respect to documents and source, we got 0 linkage. So that was not relevant for the analysis. Therefore, we removed it for the result part for this presentation. Then comes another set of analysis, which is the bibliographic coupling. So bibliographic coupling means when there are 2 publications which cite the same third publication. Okay. So what will be reflected here as analysis is going to be that third publication which has been cited. So this helps us to understand the weight of that document amongst the peer group or the peer members. So bibliographic coupling therefore plays a very vital role. I repeat again, because it will help us to understand that paper A, how relevant it is when other peers are reviewing it or they're evaluating it. So if I'm able to cite it more, it means that it's a relevant paper, it is a quality paper, it is a benchmark paper. So all our analysis will be then seen with respect to document, sources, country, etc. And the result that will be depicted is going to be that author or that source or that document that is being referred. So bibliographic coupling result comes with a graph. So now here, if you see, the graph is much more denser compared to the previous graphs that we've seen. However, no linkages are seen. So, which is fine. There can be no network also in our analysis. So if you see here from these many authors, the document that has been recommended the most and has been cross-cited by 2 authors is Amir Varsini 2020, bigger in size, followed by Borghi 2022, followed by Jahan Bakshi 2021, Binder Shahi, Chakurtala. So if you see here, spheres will depict the strength of the entry that has been referred to. So this also helps us to understand which article holds importance. And also remember, 187 is huge list of articles. So if I'm doing a research and I want to note down certain important papers for my own understanding, I will be actually referring to papers which have been cited the most or papers that have been referred the most. So considering this as the most referred paper, some spheres which are brighter, okay, that we can go ahead with the initial reading. Then comes bibliometric references with respect to source. So when we say source, we are talking about the journals which will be actually publishing these articles. So if there are 2 authors, and now what the analysis has done is, that was author-based analysis, 2 authors referring a third author, then 2 authors referring article from a particular journal. So this also helps us to understand which journal actually publishes quality paper that can be referred, reviewed, read, okay, and incorporated as part of the methodology. So a lot of times researcher ask why bibliometric analysis is important. We can just do normal review and get work done. Bibliometric analysis help us to understand the strength of these articles, help us to understand the quality article, help us to understand an entire story. So if I know a citation of a journal is really high and this is where it is meeting, so I should be actually working in that domain. That's how foreign university actually initiate their research scholars to first do bibliometric analysis and systematic analysis, unlike in India where we don't refer that much except for the management people who do that in India. So therefore, I recommend everybody to go for a bibliometric analysis before even starting their research. It'll help them to understand the important aspect of the research topic that they wish to do. So when we go ahead, coming back here, now I've given why it's important for us to understand these matrices. So bibliocoupling with respect to sources means that the Journal of Food Composition and Analysis is the one that was most referred to among those 187 data set that I had given to the software. Then food control also was the most referred one. Food chemistry was the most referred one. Now this is not based on the citation. This is based on the references column that has come from that paper. Okay, so all these analyses that we're talking about, which is bibliographic coupling, they are actually based on the references of the article A and B. Then comes your bibliographic coupling with respect to authors. So with respect to authors, this is how it's referring to. So this author has been the most referred author. So you can actually start with reading his paper first and then going ahead with other authors of interest. Then comes bibliographic coupling institution wise. So the articles which has referred to a particular institute or has cited the research article of that particular institute. There are two, if you see sphere wise, there are three. But the bigger one is for Sharif University of Technology. Then comes Gajal Madar University. So we can actually refer to these articles for the methodology part and other section. Okay, so bibliographic coupling helps us to not only identify articles which are referred, which are of good quality, but also adapt. So if I'm somewhere close, in this nation, I have access to same set of instrument, etc. I can actually go ahead and read their methodology and pretty much try to do with the methodology and a new novel idea of mine. So therefore, even understanding institution-wise is an important aspect because this helps us to read the methodology with that purview and with that geographical, you know, location of interest. Now coming to bibliographic coupling with respect to countries, so no doubt China will be, because they've contributed a major set of documents or research articles or entries. Therefore, they will be definitely the more referred ones. So if you say China, India, Iran, these are the most bibliographic company countries that are seen. So now this is important for a researcher perspective. If I want to now initiate my research and I want to collaborate with somebody, I will be opting for these institutes because they are actually actively working in the past 5 decades for machine learning and food adulteration. Of course, in food adulteration also, I will discuss what are the various types of food products that they talk about. But this way, we'll get an overview of the entire world perspective of publications that have been done. Now, I've only incorporated research articles. Our analysis only go for research articles. We exclude review articles and non-English articles because we can't read their abstract. So, for relevant reason. Okay. Then comes our content analysis. So, this analysis is important. Now, of lately, the analysis that I've shown can easily be computed in WOS Viewer. All we have to do is just clean the data and then it's just a click away to get these networks. But for content analysis, you'll actually have to review the paper. So when I say review the paper, it means you'll have to be reading the paper. So remember, I started off in 1st October and it took me a month to do that. Of course, somebody who's more dedicated could do it at a greater pace because I was currently working at that time. Therefore, it took me a lot of time to actually review these 187 paper and then come up with the content analysis and other analysis that is required. So till this analysis, which is your bibliographic coupling, the software is going to take care of everything. But when it comes to content analysis, you'll have to sit and invest your time. You'll have to read those articles. their abstract and then come up with certain themes. So what we came up with was we decided to segregate the content with respect to the category of food that people are working with. Second, we also wanted to do content analysis with respect to the analytical tools that are there. Content analysis, we try to do it with respect to the algorithms that we use, but now people are using these mixture of algorithm. Therefore, segregating them became very difficult. So we have reviewed that and not made a content analysis out of it. So what you see here is a decision tree, and this is the classical table. So the food category that people have worked the most is going to be oil, followed by dairy products, followed by condiments, spices, uh, beverages, grain flour, fruits and plant products, sweeteners, meat and poultry, dry fruits, fish and seafoods. So if you see here, the most dense is oil. So as a researcher, if I want to choose a novel uh, you know category, I would not be working with the one which is most usually used. And even if I'm using the most usually food category, which is oil, there will should be a novelty that you are putting up in the world to review and read and consume. So this analysis is important. It helps us to understand which is the most favorite food category which is studied. That can be of methodological issue. That can also be the laboratory issue, how much the lab has, and also a major chunk of issue like adulteration is most going to be common among spices, among dairy products, among oils. So in this purview, we try to read. So I've seen and I've read papers in Indian context and national context. So this is just the same that is reflecting here. We've also worked with oil, and we and our lab have worked with oils, and we worked with spices and condiments, and used ML model, which is support vector machine, in order to analyze the results. So we've done our part, but it's still less compared to what others are doing. Now, if you see, so this is a decision tree, very clear to understand. The darker on the map, so darker the blue, the more is going to be the category percentage wise. Now then, that's a bubble map that was made. Now this is made using Tableau. So another visualization too. This is not done in VOSviewer. The analytical bibliographic was done in VOSviewer, and from now onwards, we've tried to review it in Tableau, and after reading the abstract and the articles in depth. So when we did the content analysis for analytical methods that have been used, we realized that it was the vibrational spectroscopy, which comprises of your IR, infrared spectroscopy, and Raman spectroscopy that is used the most. So these two spectroscopy was the most exhaustively used one. One could be that we are able to do it much more easier or more efficacy. Then comes AT-FTIR. So AT-FTIR has zero sample preparation. Your classical IR spectroscopy should be one in which we are more reliant on making the sample preparation in KBR pellets, which is very taxing. But now with AT-FTIR being available in all the labs, and you can do all the analysis in this, so a lot of research work is also being done in domain of AT-FTIR spectroscopy. So as a new researcher, I would actually work from top to down approach. So if I want to take something here from today, I can clearly see what are the various analytical methods that have been used, which is much more possible in our lab itself. So in our lab, we've done using AT-FTIR spectroscopy for oil samples and for spices. We've done using that, but ours was a more pilot study. We didn't extend it much. So we had maximum 50 to 55, 50 to 100 samples that we've run, which is less for a chemometric and an ML model to run. So we're looking forward of increasing it more. So if you see here, so this clearly states that we can go ahead with the vibrational spectroscopy. There is zero sample preparation, especially for AT-FTIR spectroscopy. And Raman spectroscopy is 13, which is good. When we talk about others means these are going to be new, unique spectroscopy that were introduced, like tetrahedral spectroscopy, ion exchange, etc. Hyperspectral imaging, which is very interesting. So we can actually use imaging for finding an adulterant and a non-adulterant sample. So it's very novel, and not everybody works on this domain. Then comes the portable IR and Raman spectroscopy, which contribute to 9.38% of the document. So their methodology included this portable high performance liquid chromatography for your liquid samples, 4.6%. So I'm assuming this could be used for your dairy products and milk products. Gas chromatography for volatile compounds, 4.69. Then electronic noise have also been used. Fluorescence spectroscopy, 2.01, and differential scanning colorimetry, 1.04. So this is interesting layout of what are the various analytical methods that were used. So for me to run an AI model, I need any of the result coming from these analytical tools, then only I can run it. So be very clear that when we are doing analysis of adulteration, we have to use these analytical tools, and on the spectral fingerprint, okay, or on the retention. Now in case of chromatography, it's not going to be the spectral fingerprint, it will be your retention times. That will be used for the machine learning algorithm. Okay. So now moving on to the future trends and the current trend that we had found out. So the algorithm that was used most commonly was partial least square discriminant analysis, and in that also the recent trend was using it with OPLS-DA for noise reduction and improving the model interpretation. When I say noise reduction, it means those additional peaks will be reduced by doing an algorithm transformation. What we had used was Jupyter Notebook for running, and these are done in your Python codes. So for running an ML, you will be using Jupyter Anaconda, and then Python codes are used for taking those spectrum and then pre-processing them as various algorithm and then making the matrix. Then support vector machine. Now support vector machine is actually also been recently used with hyperspectral or spectroscopic data for robust detection. This is analysis from our paper that we got. So what we did was we had to review the type of vector, algorithm, the machine learning algorithm, both supervised and unsupervised model that people have used, and then seeing the current change, how they have tandemly played with that model and combined it with other model, etc. Then multi-class SVM, this can also be used. Linear discriminant analysis was also used in the publication. Quadratic discriminant analysis was also used in few papers. And now they are of lately combining it with PCA or PLS-DA. PCA, very few papers talked about PCA alone. It always was talked in tandem to either PLS-DA or SVM. These are all algorithms that you do for discriminating adulterated versus a non-adulterated sample based on the spectral profile that you get, or based on the retention values that you get, or based on the images that are there in hyperspectral imaging, etc. Then soft independent modeling of class analogy. This is used also in tandem to PLSR. Decision trees, there were papers which had used decision trees such as random forest. Naive Bayes was also used in few trees. Now not all papers, but very few people had naive Bayes, K, neighborhood and random forest. All of them are your supervised ML. Artificial neural network was also used, in which CNN was most commonly used. Then there was genetic and algorithm based inverse least square, but very few people talking about them. The most commonly used ones was PLS-DA, SVM, OCSVM, MSVM, LDA, QDA, and less were talking about these. However, decision trees were also used. Okay. Then comes partial least square regression, principal component regression, and orthogonal partial least square discriminant analysis. These were certain algorithm that we came across, but the most prevalent one was the slide number 1 that I had shown, followed by them in the descending order. Now, these algorithms usually, what we had seen when we had reviewed the content was that now people are actually playing with supervised model, and it is supervised model that will be used, because you'll have to segregate your data into, you'll have to first train the algorithm for identifying an adulterated and non-adulterated sample, and then predicting a blind sample. So These models could be applied in Jupyter Notebook using Python codes. However, running them can be a little difficult because they are case sensitive codes. And also, we need to do some modification and pre-processing of the data before running these algorithms is what we faced. Of course, I don't run the Python code. I run only the non-transformed one. We send it off to a collaborator in order to get a more refined algorithm result. So with respect to conclusion, the future of food adulteration detection is characterized by increased automation, integration of multiple technologies, and smarter real-time solutions, which is very evident. We spoke about hyperspectral imaging, spectroscopy, chromatography, e-noises, and they are combined with AI. When I say combined with AI, it means that their results are now interpreted with AI, and more precisely in AI, it's the machine learning domain that is used. And that can be really accurate, portable, and scalable detection system. Now, the advancement in AI explainability, data fusion, and cloud technology has made things now much more easier and accessible for us to use. These are some of the references that I've used for this presentation, and thank you. So that's all. I hope I was able to do justice, and some part was clear to all the speakers. So I'll